contains. That means it is on the inside. Surface area is only on the outside. Volume is on the inside. Since you are caring about all the space inside, volume is 3 dimensions. Because we care about the length, the width, and the height. Now, volume is a little dodgy because volume gets thrown around. Volume usually refers to a solid. If I have something that is empty that I am filling up, then we usually use the word capacity. Refers to the amount you can fill something, which is different, right? If I have the lid on my coffee cup has a volume, yes? It is taking up a certain amount of space in our universe, right? Is the capacity of my coffee cup the same as its volume? No, because the coffee cup has walls, right? I can only fill it so much because it's thick. Everybody understand? Everybody with me? All right. Now, if you wanted to get super technical and I took the lid off of my coffee cup, is that empty space in there technically the volume of the coffee cup? No, it is not. Does everybody understand? But does the coffee cup still have a capacity? And that capacity is the empty space. Right? And that capacity would be the volume of that cylinder. Does everybody understand? It's a little snaky, right? So we like to be a little careful with that. But the thing to remember, it is 3-dimensional. Since it is 3-dimensional, it is units cubed. Everybody good? Now, volume is way easier to find than surface area. Way easier. And let me prove that to you. Here in my hand, I have all of the quizzes. Agreed? What shape do all these quizzes make when I put them together? A rectangular prism, yes? And that rectangular prism is taking up this amount of space in the universe. Everyone agree? Okay. What shape is that? Just a rectangle. How many dimensions does it have? 2. Because you cannot see how thick it is. Agreed? Right? 2 dimensions. Length, width, yeah? So you know that this is 11.5 inches. So my piece of paper is 11.5 by 8.5, right? Everyone cool with that? Now, how big then is this area? How are you going to figure that out? It's easy. You're going to need to use your calculator because there's decimals involved. But what is it? 11.5 times 8.5, right? It's actually, it's only 8.5 by 11, but that's cool. Doesn't matter. What's this value? Pardon me? 97.75. Does everyone agree? Yeah. And when you look at it right now, that is all you can measure, yes? Because you can't technically see how thick this is. Everybody good? Now, what shape is this? A rectangle. If I repeat that rectangle, what happens? What do I build? I build a rectangular pyramid, yes? Rectangular prism, yes? Right? So, since you know one of these has an area of 97.75, if I repeat it 60 times, what do I get? I get 97.75 times how much? Times 60. I took the base and I repeated it, right? Everybody understand? Now, if that happens once in math class, how often will it happen? Take a guess. How often does a fact repeat if it happens once in math class? Always. What shape is that? A circle. What if I take that circle and I repeat it a certain amount of times? What do I get? A cylinder, right? Everybody with me? What if I have a triangle, like a Toblerone bar, and I repeat it? What do I get? A triangular prism. So, since you now know that this is 97.75, and if I repeat it 60 times, I get that same 97.75 60 times, yes? So that's how much space this rectangular prism is going to take up. So that means that a volume of a prism must equal the area of its base times what? What direction did I repeat it? The height. Now the trick here is the area of the base is what? That is at the bottom? What is it? What does base really mean in this case? Starting shape. It's the starting shape. And that is 2D, isn't it? It's length times width. But once I multiply by the height, which isn't necessarily the height, what is height really? It's the direction of what? It's the direction of the repeating. That gets us our third dimension. Does everybody understand? If it's a prism. We talked about two things though, didn't we? What's the other thing we talked about? Pyramids. What about a pyramid? Now, we know that a pyramid starts with a base, yes? What happens to that base shape? It shrinks, which means a pyramid that starts from this piece of paper and goes up must have more or less volume than its related prism. Less, right? Has to be, because the shape is getting smaller and smaller and smaller. It turns out, if you do experiments, which is how all the formulas were brought about, a pyramid is the exact same as the volume of a prism divided by 3. So you use the exact same formula, but if it's a pyramid, you have to divide your final answer by 3. Everybody good? So that's why, one sec, Ken, when you look on your formula sheet, you see that all the formulas for volume just say area of base times the height. They do not give you a formula like they do for surface area. Ken, go. No, because it is repeating straight up. Is everybody cool? Okay. Return to the previous 5 questions. I think there's only actually 4. But not till the end of tomorrow's class. So let's go back. Here is our first one. We're going to do the volume. We need almost no room to do volume because it's super easy. All of you already know the volume of a prism. You already know that the volume of a rectangular prism is length times width times height. But what is it really? If I use the blue rectangle, it repeats in what direction? Back. So it would be 24 times 40 times 8, right? If I use the yellow rectangle, it repeats in what direction? Left. So it would be 8 times 40 times 24. If I use the green rectangle, it repeats in what direction? Down. So it would be 24 times 8 times 40, right? Does order ever matter when we multiply? No, it's commutative. 2 times 5 is the same as 5 times 2. So that's why the volume of a prism, we say if it's a rectangle, it's length times width times height. But in reality, it's just the area of the base times the height. And the base is any face from the pyramid. Because no matter how we do this, it's going to be those three numbers multiplied together. And of course, what is that answer? 40 times 8 times 24 is 320 times 24 is 300 times 20 is 6,000. And I can't do that in my head today. I'm too tired. 6,680? 7,680 centimeters cubed. Everybody cool? That's an easy one, right? All right. Now we got a pyramid. What do we know about a pyramid? It's the same as the prism related. So whatever prism you have that starts the same, but divided by 3. So this is a rectangular pyramid, so it's related to a rectangular prism, right? The volume of a rectangular prism is LWH, yeah? So LWH divided by 3. What's the L? $48. What's the W? $32. What's the H? $65. And that whole answer is then divided by 3. Now I think on your data booklet it writes it as 1/3 area of the base times the height, right? Of course you know that multiplying by 1/3 is the same as dividing by 3. So you find that answer and you get it by going to your calculator, whatever it may be. It's big. 50 times 30 is 1,500 times 6. It's going to be around 9,000, 10,000. What is it? 13,000 and something? What? Oh, I forgot a zero when I did 50 times 60. Stop it. Or 1,500 times 60. What is it? 32. What? What? Centimeters cubed? Inches cubed. Feet cubed. There we go. All right. What's a cone? Pyramid or prism? What is it? Pyramid. So the volume of a cone must be the volume, the area of the base, right? Oh, wait a second. What did we do wrong here? No, we're fine. It's the area of the base, right? Times the height divided by 3. What's the area of the base? What shape is on the base of a cone? Circle. So what is it? What? Pi r squared times what's our height? 22. What was our radius? 15, wasn't it? Times 22 divided by 3. 15 squared is 225. 225 times 22 is whatever it is. What is it? This is 15 squared. What's 225 times 22? 4,950. 950 pi, because we're not going to be using pi, divided by 3. What's 4,950 divided by 3? 1,650 pi. And that's where we want your answer to be this year. What if you're doing a test that doesn't have that as the choices? Then what are you going to do? Then you're going to do 1650 times pi button. Right? Because there's the real life answer and then there's the math class answer. Everybody good? Volume of a cylinder. Is a cylinder a prism or a pyramid? Is a cylinder a prism or a pyramid? Prism. So is there any division involved? No. It's area of base times the height. What's the base of a cylinder? Circle. So what's its area? Pi r squared times height. Pi, what's my r here? 5 squared. And what was my height? 20. What's 5 squared? 25 times 20? 500. 500 pi. If I need the decimal answer, I do 500 times pi. Regular shapes are super easy, yes? That's all there is to them. This is what is key. It doesn't matter what the shape is. If it's a prism or it's a pyramid, you find the area of the base, multiply by the height, and then sometimes you divide by 3 and sometimes you don't. If it's a pyramid, you do. If it's a prism, you don't. Now, is it possible to have prisms that are weird shapes? Yeah, because a prism just has to be a repeated shape, right? It might not have a name. What if I were to give you something like this? And I made that a prism. Is it a prism? What shape repeats? This, right? So this is the base. I have to wait a second, Jesse, because this is going to be on your assignment, and 27 kids are going to ask me how to do it, even though I'm showing them right now. So I have to wait for them all to be quiet. That shape repeats, right? What direction does it repeat? That way. So there would be my base. There would be my height. Except this shape doesn't have a formula, does it? But isn't it a rectangle and a triangle? Everybody understand? So if I could find this area, and then I could find this area, and I added them together, would that get me my base area? And would that then multiply by my height? So remember, you have all the tools you need to do all of these. Some of them are just going to look a little funky. Everybody good? All right. So now we have covered. Please turn back to volume. We have now covered surface area of prisms, surface area of pyramids, volume of prisms, volume of pyramids. Now we got to talk about spheres. Remember how when all the pyramids and the prisms, we flattened them out and drew all the shapes? You can't do that with a sphere. Because when a sphere is flattened out, what do you have? A circle. The circle's just stretched, right? So when they worked out the formulas of this, it was all done with experimentation. There was no way to build them. So you just got to trust them. Now there's a problem with these because they aren't as simple as one might think they would be. First of all, you see pi is involved in both of them. That makes sense, right? Because they're circles. And it's real easy when we're talking about full spheres. But sometimes we deal with hemispheres, like on our planet. So I like to spend a moment to talk about hemispheres as well. Hemispheres are, of course, half a sphere. Right? How do we mathematically cut something in half? We divide it by 2, correct? So the surface area of a hemisphere logically must be 4 pi r squared divided by 2, correct? Logically. If a whole sphere is 4 pi r squared, half a sphere must be divided by 2, right? Which would be 2 pi r squared. Everyone agree? But look, I'm going to cut off the top of our sphere here. And if this sphere was solid, what did I just make right there? I made a new surface, didn't I? What shape is that new surface? A circle. So I added what? What's the area of a circle? I added a pi r squared, didn't I? So if I got 2 pi r squareds and then one more pi r squared, how many pi r squareds do I have? 3. So a solid hemisphere actually is 3 pi r squareds, not 2. Everybody understand? Now the real tricky question. Technically, what if it was hollow? What would the surface area be? Levi? It would be exactly the same, wouldn't it? Because it's inside and outside. Everybody understand? Tricky, hey? What if I want to do the volume of a hemisphere? Well, here's my volume. So logically, what should I do to that? Divide it by 2. Now let's stop and think about this for a minute. In volume, if I cut it in half like I've done over here, is any new volume created? No. The volume is only lost. So this stands for volume, doesn't it? But this is a barfy way to write it, isn't it? What is the same as dividing by 2? Multiplying by what? 0.5, or better, what's 0.5? 1/2. So isn't this 4/3 pi r cubed times 1/2? And where is this pi r cubed? Is it with the 4 or is it with the 3? Is that numerator or denominator there? It's numerator, isn't it? So this is 4 pi r cubed over 3 times 1/2, right? Well, in a fraction, where do what happens with the two numerators? They multiply together, so it's 1 times 4 pi r cubed. 4 pi r cubed over, what's 3 times 2? 6, right? Would you ever leave this fraction? What is 4 over 6 really? 2/3. So the volume of a hemisphere is really 2 pi r cubed over 3. Everybody cool? That's not on your sheets. You're supposed to be able to figure that stuff out on your own. That has not been the case, I have noticed, in the last 20 years I've been teaching this course. So I show you how to do it now. Everybody good? Now, as always, we'll do a couple of questions together, and then I'm going to shut up and let you work all the rest of today and all day tomorrow. So turn over to 33. And you will notice we are well past halfway through this unit, yes? Which means, no. It means I have to start thinking about my next unit and adding some wrinkles. And the wrinkle I am going to add here, even though we're talking about volume and surface area, I'm going to add the wrinkle of algebra. Because all of you need to be reminded of how to do algebra. Let's talk about this question. First of all, it's a stupid math class question, because who would ever wrap a basketball? That's dumb. You would either flatten it out and wrap it, or you would put it in a box and wrap the box. You would not try to wrap the basketball. That's a stupid thing to do. It also isn't it makes it pretty obvious what it is. But, we're going to use this to practice our algebra. So read this question. Will I be doing the surface area or the volume of this basketball? Why would it be surface area, Jordan? Because you're not wrapping the inside. It's only on the outside. So I must be doing the surface area of a sphere. And what does that equal? 4 pi r squared. Right? Do I know the surface area that I need? Read the question. Do I know the surface area that I need? What is it? 2,500. And that equals 4 pi r squared. What do I need to find? Radius. Since I need to find the radius, that means I must isolate r. So we're going to practice some algebra. And this will cause much grief. How do I get r by itself? I do the inverse operation of what I see. Algebra is so easy. I don't know why people say it's difficult. The question tells you what to do. You do the opposite of what you see. What math is happening to that 4? So what do I do? Divide by 4. What do I got to do to the other side then? Divide by 4. What math is happening to pi? Multiply. So what do I do? Divide by pi. What math is happening to r squared? It's being squared. What's the inverse of squaring something? Square root. So I square root that. So what do I do over here? Square root that. So what is r? The square root of 2,500 divided by 4 pi. Is that a real life answer? It's a math class answer. You would use your calculator to get the real life answer. Is this question a time when I would want a real life answer? Yes. Everybody good? You got to punch that into your calculator. Of course you do that the same way you punch everything into your calculator. You start on the inside and you then square root. Now, listen to me carefully. This is the right answer, isn't it? But when I say tell me the answer, I'm going to get a bunch of different answers, even though you're all punching it into your calculator. Is it because your calculator is stupid? Is it because you can't read those numbers? No. It's because you're not totally comfortable with punching a lot of stuff into your calculator at once. So everybody, tell me what the radius is. I want to hear some of your answers. So Jordan has our radius at 3.98 centimeters. What else we got? We got 14.1 centimeters. What do you got, Colin? You've got 25 over pi, which you would then do on your calculator. Okay, now, Jordan, you've seen basketballs. Do they have a radius of 4 centimeters? That means a basketball is this big. I'm not trying to put you down. Is that a sensible answer? No. Now, if it was 14, that means a basketball is this big. Is that a sensible answer? Yes. Now, why, Jordan, could you possibly have gotten that answer? Exactly. It's not that you don't know how to do math. You're not comfortable with your calculator. Right? When you were doing this on your calculator, it is 2,500 divided by bracket 4 pi. You got to put the brackets, or your calculator is going to do 2,500 divided by 4 and then multiply that by pi. Because your calculator always does BEDMAS. Your calculator isn't smart enough to know what you want to do because your calculator is not intelligent. It is just a machine. Just like if you have a pair of scissors, you can't say to it, hey, can you cut out some paper dolls for me? No, you actually have to do it. And then once you have that answer, you got to square root the whole thing. Does everybody understand? All right, turn the page over. Try working with your neighbor, because this question puts together the last 2 lessons in one question. I love it. how big the ball is. It fits perfectly. How wide is the box? How wide is the box? 3 centimeters. The golf ball fits perfectly inside it. So how wide is the golf ball? So what's the diameter of the golf ball? 3 centimeters. What's the radius of the golf ball? Look at you! And how many golf balls are there? 3.
Yeah.
So you have 3. What shape is a golf ball? So you have 3 spheres of volume. Right?
Yeah.
There you go.